Hello dear students, algebraic expression. Objective: simplifying or reducing a rational expression p of x over q of x. Simplifying or reducing a fractional expression. In order to simplify the expression f of x equal p of x over q of x, we should follow the following three steps. First, factorize the numerator, so factorize p of x, and the q of x, factorize the denominator. Then, after factorizing p of x and the q of x, find the values of x for which f of x is defined. We have rational expression, so any rational expression is defined when its denominator does not equal to 0. This means the q of x does not equal to 0. After finding the domain of definition, we will simplify all the common factors. Example, we have two polynomials p of x and q of x. We want to factorize p of x and q of x. Then we have a fractional expression p of x over q of x. Find the values of x for which f of x is defined. Or in another way, find the domain of definition of f of x. And the last one, simplify f of x. Okay. Solution. P of x and q of x are given. Factorize p of x and q of x. I will factorize p of x. Okay. P of x equal to x minus 2 squared minus 9. We know the remarkable identities. The third remarkable identity, which is different between 2 squared, we have a squared minus b squared, which is equal to a plus b into a minus b. Okay. 9 equal to 3 squared. So you will open a bracket and write a plus b into a minus b. This means x minus 2 plus 3, because a 3 squared equal to 9, and x minus 2 minus 3, okay, plus 3 minus 3. By simplifying inside the brackets, x minus 2 plus 3, which is equal to x plus 1, and x minus 2 minus 3, x minus 5. Okay, reducing inside bracket. Now we will factorize q of x. Q of x equal to x squared minus 25. It's very easy. X squared minus 25, which is equal to a squared minus b squared. Okay, you can write it as a plus b into a minus b. X squared become x and 25 become 5. So x plus 5 into x minus 5. Now we have the factorized form of p of x and a q of x. 2, we have f of x equal to p of x over q of x. This is fractional expression. Okay, I will replace the factorized form of p of x and the factorized form of q of x. It become f of x equal to x plus 1, x minus 5, divided by x plus 5 into x minus 5. Now, before simplifying the common factor, we will find the domain of definition, or find the values of x for which f of x is defined. This means take the denominator does not equal to 0. So f of x is defined when x plus 5 into x minus 5 does not equal to 0. So x plus 5 does not equal to 0. This means x does not equal to minus 5. X minus 5 does not equal to 0. This means x does not equal to 5. And the last one, now you can simplify f of x after finding the domain of definition. So, simplify the common factors. We have x minus 5 in the numerator and x minus 5 in the denominator. So, the answer will be f of x equal x plus 1 over x plus 5. Now, we have evaluation. We have p of x and the q of x. Factorize the two polynomials p of x and the q of x. H of x equal to p of x over q of x. Determine the domain of definition of h of x, or in another way, find the values of x for which h of x is defined. And the last one, simplify h of x. Pause the video and start to solve the evaluation. Now I will complete solution. First one, we have p of x. by factorizing p of x, we have x squared minus 4 plus x into x plus 2. We don't have any factor, but we have x squared minus 4, which is difference between 2 squared. So it's equal to x minus 2 into x plus 2. Now we have a common factor x plus 2. Take x plus 2 as a common factor. From the first one, x minus 2. From the second one, x. Okay, by reducing inside the brackets, x plus 2 into x minus 2 plus x equal to 2x minus 2. And the second parenthesis, you can also take a common factor 2 to become 2 into x minus 1. Put the number before the 2 parentheses, so the factorized form of p of x is 2 into x plus 2 into x minus 1. About q of x, we have x minus 1 squared plus 4x minus 4. Okay, now we want to have a common factor. X minus 1 squared plus, you can take 4 as a common factor to become 4 into x minus 1. Now we have x minus 1 as a common factor. So x minus 1, open bracket, from the first one because it's squared, so we have x minus 1. From the second one, we have just 4. Okay, reduce inside the brackets, x minus 1 into x minus 1 plus 4 plus 3. So x plus 3. Then we have the factorized form of p of x and q of x. Now we have h of x equal p of x over q of x. Okay, so replace p of x and q of x by the factorized form. P of x over q of x equal to 2 into x plus 2 x minus 1 over x minus 1 into x plus 3. This is p of x. This is q of x. Okay. The domain of definition, determine the domain of definition or find the values of x for which h of x is defined. So, I will take the denominator does not equal to 0. This means x minus 1 into x plus 3 does not equal to 0. So, x minus 1 does not equal to 0. This means x does not equal to 1. And x plus 3 does not equal to 0. This means x does not equal to minus 3. Okay, after finding the domain of definition, okay, I will simplify. So simplify h of x. Now, after finding the domain of definition, you can simplify the common factors. Okay, in the numerator we have x minus 1 and in the denominator we have x minus 1. You can simplify. So p of x over q of x, which is equal to h of x, okay, equal to 2 into x plus 2 over x plus 3. Thank you.